Hello everyone, welcome back to Developers and Coders Club NIT's Agartala's YouTube channel. Today we will discuss Codeforces round 906 division 2 second problem, Qingshan loves strings. So let's take a look at the problem statement. Qingshan has a string S while Daniel has a string T. Both strings only contain 0 and 1. A string is considered good if AI is not equals to AI plus 1. Basically, adjacent elements of the string of length k are not equal. Like for example, all the alternative elements are not equal, but this are not the good strings. Okay. So, Qingshan wants to make S good. To do this, she can do the following operation any number of times. Insert T to the position of S. Please tell Qingshan if it is possible to make S good or not. So let's take a look at the input. Firstly, we'll take the input of test cases, then integer n and m, s, length of first string and length of second string. And if it's possible to make such a good string, then we'll print yes, otherwise no. So in this first like this, we'll take a look. So like in this one, this first E, so basically we have been given two strings of 1 and 1 length. So basically size is only 1 of S. This is S. 1 S is equals to 1 and T is equals to 0. So basically if I don't insert any other string, then also this will be good only. So we can simply print yes. In the second test case, we have length of S as 3 and length of T as 3. So basically 1 1 1. It is not good as these two elements are same, adjacent elements are same, and these two adjacent elements of string are same. So what we are going to do is we will add here this string T. So 1 0 1 0, and we will add here also. So 1 0 1 0. So now this string is good. Every alternate element is unique, and likewise. Okay, so this case is done. Now in this case, here T is only T is not T contains 0 and 0, so adjacent element is not unique. So basically if anytime I insert in it, every time it will be never going to be a good array. Okay, so this is a case. And in the last one, likewise if I insert it here, let's say 1 0 and then 1, and if I insert T over here like 1 0, so 1 and 1 will collide, so we will simply say no. And in the last test, and so on. So what we basically observe here is, let's see on a new page. Let's take a look on this test case. This one. So in this one, we can say that what we are going to do is, we'll see that in the string if the adjacent element are equal or not, or if it's equal, we are going to count it. How many times it is equal? It is equal here 1 and 1, like 0 0 1 1 0 0. Sorry, this one is 1 So basically if I count it, it is 1 and then it is 2. So 2 times. And string T have all the alternate elements. So okay, if we count it here, it will be 0. So I will insert firstly string here and then here. But we will also make sure that the first element, the element which is here, is not equal to the first element or the last element of T. What I basically means is that if I insert here, it says 0, 1, if I insert here T, so it will collide with 1 if this is T and this is S. So here 1 and 1 will collide, and also the last element is 1, like then 0 and then 0. So and 0, 1, 0, 1, T is this. So this one will also collide with this one, so it should not also collide with this. So keeping in mind all these test cases, let's see the code. So basically first we will take the input of test cases, then we'll take input of N and M, the strings S and T. We'll have 2 counter and 3 the counter's flag. We'll see if one element is equal to the adjacent element of the string, then we will increase the counter S1 if in S1 it is equal, and if in the another string, that is in string T, if it's equal, we'll increase the counter. Now we can see, like if we have an example like this, if S is equals to 1, 1, 1 and T is equals to 0, 0, so we can simply say that we can simply output no, because T itself is not unique. T itself don't have adjacent elements as unique, so we can simply say print no. So that's what I have in my this test case, that if T1, that is basically T1 will be equal to 0 in that 0, 0 test case. So if this is equals to 0 and if S1 is also is not equals to 0, then we'll print no. But if S1 like if in this test case, like if I have a case like this 1, 0, 1, 0 and I have S is equals to this and I have T is equals to 0 and 0. So here I don't have to insert it. So in this test case we can print yes. Here S1 will be 0 and T1 will not be equal to 0. So T1 not equals to 0 and S1 equals to 0, will print yes. In another test case, if S1 is 0, we don't have to look for T1, okay? So we will print yes. In the last case, that is if T1 equals to 0 and S1 is not 0. So what we are going to do is, we are going to run a loop in which we will check if the first element is equals to its next element, then we'll see that first element is equal to string's first element, or if it's equal to string's last element, then we'll increase our counter flag. If that is how this is working is, let's say I have this. So basically these elements are equal and I have T is equals to 1, 0, 1. This is S. So we will see that if this, that is if I take it as X, if X is equals to 1, is equal to this, that is first element of string T, or if X is equal to the last element of string T, then we'll increase our counter flag. And if it is so, we will simply say no. We will simply print no. So if it is, so if our flag value has increased, then we'll print no. Otherwise, if it is an increase, we'll print yes. Like if I have S is equals to, let's say if I have s is equals to 1 0 0 1 and I have t is equals to say 1 0 1. Okay, we can have an example as this. So what we will see here is, yes, there are elements which are equal. Now we'll compare it with this first element and this element. Okay, so now both of them are different, so flag value will remain 0 only. So for flag value equals to 0, we're going to print yes. So let's run the code. So yes, it works. Thank you.